So this question of how large does n have to be within a specific error bound that you specify, what we're going to do is I'm going to look at, so I already did the trapezoidal rule with n equals 10 of the function of the integral from 4 to 6 natural log of x cubed plus 2. And when I got that the trapezoidal rule was 9.649753. So my n was 10 in that case. And so my error, my very specific error that I calculated based off of the answer I got in the calculator, was 0.000772. And so now I'm looking at this and going, you know what, that error is a little too high. I would rather have 0.0000 something. I want the error to be smaller. So I asked myself the question, what would this n have to be to get that smaller error? So we're going to use our error bound formula here. So the absolute value of the error of the trapezoid has to be less than or equal to capital K of b minus a cubed all over 12n squared. So I've shown previously that we can use Desmos to find the second derivative because k has to be greater than or equal to the absolute value of the second derivative of f of x. So I'll leave that for you to find in a previous video, but I got this k equals 0.17. So again, I showed how you can graph f of x, graph the derivative, and then find the max of that second derivative. And so that's what we're using for our k. So I'm going to use this formula. I'm going to say, okay, k is 0.17. My limits went from 4 to 6, so it's 6 minus 4 cubed, all over 12n squared. But I want to specify how large I'm going to allow the error to get. And so in this case, like I said, I wanted to get one more 0 in there on my error to make it smaller. So I'm going to say, you know what, whatever that value is, it has to be less than or equal to 0.00001. You could say 0.05 or whatever you want, but I already saw that with n equals 10, I was getting this 0.0007 approximately, or 0.0008, you could say. I just want to get it slightly better, so I'm choosing 0.00001. So that 1 doesn't have to be a 1, that's just a common thing that we do, because why would you put a 9? We might as well just make it smaller and make it a 1. So this 0.00001 that I chose, that's usually provided to you when you're doing your problems. Okay, now I'm looking at this going, okay, I have one unknown of that n. I'm going to solve for n now. So 0.17 and 6 minus 4 is 2 cubed. So 0.17 times 2 cubed would be 1.36. And then I'm going to take that 12n squared and multiply it to the right side. So 0.00001 times 12 would be 0.00012n squared. And then I'll divide that 0.00012, and the left side becomes this 11,333.333. I could leave it as an exact fraction, but I'll just, it doesn't really matter. And now I'm going to take the, well, I'm going to switch this over. So n squared has to be greater than or equal to 11,333.33 repeating decimal. And then take the square root of both sides. I get n has to be greater than 106.46. And so n has to be a whole number. So it just has to be a whole number bigger than 106. And so, okay, I got it. N has to be, that's a lot of n's. That's, could you imagine doing all that by hand? It's tons. This is where I could stop. I could say, okay, I found how big n has to be. And notice that it's going to be dependent on what you choose your k value to be. So if you go slightly higher k, like if I did 0.18, that would change my n value. So you might get slightly different answer than the back of the book if you have a different k value. But as long as it's the greater than the max of the second derivative, you'll be fine. So this here, what I want to look at now, I'm done with the problem, everything's good. let's check if this actually held true. Will I get an error that's less than this 0.00001 if I use some n greater than 106? So I'm going to say, let's let n be 107. And then I went to my Google Sheets, because it's much faster to do it that way. And this is the trapezoidal rule. I found my delta x was 2 over 107, because 6 minus 4 over my n. And so I put that all in my first column, so of course I have many iterations of it going. And then my f of x was the formula, the natural log of x cubed plus 2. My coefficients for trapezoidal rule is the first term's 1, all the other coefficients are 2 except for the last term. And then I multiplied those coefficients to my outputs. I summed my outputs. This 0.0093, that's the 2 divided by 107, all of that divided by 2, because it's the delta x divided by 2. And then I got this 9.650519 when I did all this in Excel as the answer. And when I took the that approximate answer and subtracted it from my what I'm calling my exact, which is the calculator's answer, I get an error of 0.0000067. So I get 0.0000067, and so this is my error of the trapezoidal rule using the n equals 107. And is that less than 0.00012? Yeah, it has more zeros. Or, I did that wrong. Is it less than, I grabbed the wrong thing. Is it less than my original criteria of 0.00001? And yes, it is. It has an extra 0 there. It is smaller. So it worked out well. Could we use a different n to get even closer, but still less than 0.00001? Yes. What this calculated was the n that, if we at least use n equals 107, will totally be fine. Could you use something a little bit less? Yes, you could and still be within that error bound. But that one is the least amount where we're ensured that we're going to be under that amount of error.